Hello guys, so now we are going to discuss about the capacitance of a parallel plate capacitor, and we have to find the value of capacitance of the parallel plate capacitor. So let's say these are two plates, one plate have positive charge. This is the positively charged plate, and the second plate have negative charge. So this arrangement is called capacitor. Whenever we have two conductors with equal and opposite charges, that arrangement is called capacitor. Now this plate have plus q charge and this plate have minus q charge. The potential on this plate is V1 and the potential on this plate is V2. Also we have charge density, surface charge density plus sigma, and here we have surface charge density minus sigma. The area of this plate is A, and this plate also have the area A, same area. And the separation between the plates we can take as D. The distance between the plate is D, and we have to find the value of capacitance. Now electric field always start from plus and go to the minus. These are the electric field lines which are coming from plus to minus. We have to find the value of first electric field between the plates of the capacitor. Very important formula, electric field between the plates of the capacitor is sigma upon epsilon naught. You have to keep this thing in mind. Electric field between the plates of the capacitor is sigma upon epsilon naught. Very important formula, sigma upon epsilon naught. Another thing what we have, you can also write the electric field in the another formula we have, that is potential difference between the plates upon distance between the plates. So this is another formula. This is the formula of uniform electric field. Keep this thing in mind. If the electric field is uniform, so we can write delta V by D. Okay, actually this formula look like this. This formula looks like delta V by delta X. Delta X is the distance between the points corresponding which we are taking the potential difference. Okay, so you can take 2 points and you take the potential difference and divided by the distance between those points. So this is the formula of uniform electric field. Okay, so that formula we have used as delta V by D. This is again very important formula. Now what do you have to find? You have to find C, capacitance. So we will get, first you need to find you can find delta V. So now we are starting like this, because if you want to find capacitance, you need to find charge and potential difference. Two things you need to find. So now we have first, that is for uniform electric field. For uniform electric field, what we have, E is equals to delta V by D. What is delta V? Delta V is ED. Also we know that E is equals to how much? Sigma upon epsilon naught. Now just put the value of E. So what we get? We get delta V. Now delta V is equals to what we got? Just copy the value of E, sigma by epsilon naught into D. So we have substituted this value over here and we got this thing. Okay, now this is delta V, and what is the value of sigma? We can also write what is the value of sigma. So keep in mind, sigma is equals to charge upon area. Very important. You can write the value of sigma. We got delta V is equals to charge into Q into D upon area into epsilon naught. We just substituted the value of sigma. Okay, now we can put the value of delta V in the like formula of capacitance. So what is the formula of capacitance? We know that the formula of capacitance is Q by delta V. And now just we need to put the value of delta V. That is how much we got Q, then we have epsilon naught, and then we have area into D. Q will cancel out. So we got, sorry, I think I have missed something over here. Okay, now we can write like this. Q into D upon A into epsilon naught. Now this is perfect. Q and Q will cancel out. We got the final expression, epsilon naught A by D. So this is the formula of capacitance of the capacitor which have parallel plates. Now take a situation in which we have like plates of the capacitor, and there is some dielectric medium is filled between the plates. So we have some dielectric medium, let's say that it is water. So when we fill some dielectric medium, so we get extra epsilon r in this formula. So we got epsilon naught epsilon r A by D. We got extra epsilon r. Okay, so the value of capacitance will increase when you fill the dielectric medium between the plates of the capacitor, and that increase is called epsilon r. So it's like the value of capacitance has been increased by a factor of what? Epsilon r, because we have multiplied epsilon r. The value of capacitance has been increased by a factor of epsilon r when we fill the dielectric medium between the plates of the capacitor. Okay, so you have to keep this thing in mind also.